to fill in. See here, I had 2 spots to fill in for red and then blue. So what goes in the first one for green? 6 out of 12. Without replacement. Throw it away. So now this one's going to be out of
11.
And then how many red? 4. So I picked a red one. Throw that away. So what's going to be in the bottom now?
10.
And what's going to be at the top now?
3.
Kick ass. Why the hell is there a 3 there? Because I just threw a red chip away. Pick a green that's that chance. Throw that away. Now there's out of 11. Throw that away. Now I lost a red one, so the top's got to change also. Why didn't this top change from how many? Because I picked a red, not a blue. I've still got all the 2 blues. Please let that make sense. So the bottom will definitely change when it's without replacement. The top might change if that thing is what you just lost. If you have less of them, then obviously the number's going to decrease. What are they going to always decrease by at most? I mean, if they're the same thing. By 1. And the bottoms will always decrease by 1 because each spot is picking one thing. I always get somebody that makes this one become 6 because they feel like they picked 6 things. So just don't do that. I'm always worried if I mention a mistake, it's going to make somebody do that mistake. So hopefully not. All right. Hopeful. Now, my God. So I had to do all of that before we can discuss the second new terminology piece. Remember that's what we were doing? So this has all been an aside. Okay. So we got mutually exclusive. We got another formula for our formula sheets now. And now we can talk about this other idea. This idea of independent. The word independent is like bananas. Like, where does it stop? Okay. So let me ask you this. The most common mistake people make with a question about independence. If I said 2 things are dependent on each other, people hear that as one thing can't happen without the other thing. Now in English, that would be totally dependent, right? You guys with me? So when you're a little baby, you're dependent on your mama. If your mama leaves you alone, are you going to immediately die? No. Right? So you are very dependent, but not totally dependent. So now here's what I'm saying. I always use this example because sometimes it really is controversial, and I just am like that. I like to do that. So I see somebody off in the distance walking towards me from the parking lot. And they're so far away, I can't tell if they're a man or a woman yet. They're just really, I'm like, there's a person coming. What's the chances they're a woman or a man, roughly? 50-50. And actually, they're probably that a man, real quick, they're probably that a boy is born is a little bit higher than a girl because somehow nature works out that men die younger, so it makes more of them. But we'll just assume it's 50-50. You guys with me? All right. So there's a 50% chance that the person walking towards me is a woman. All right. Now here's where the controversy comes in. Let's see if you guys really get this. Let's say that I did notice that they just came off of a Harley Davidson motorcycle. Somehow I can tell it's a Harley Davidson, but I can't quite tell their sex. But you guys kind of with me? Did the probability that it's a woman just change with that new thing I know?
Yes.
Yes, it did. Now, one semester, I love this. One semester, this girl wanted to rough me up. And she thought that I was saying that no women ride Harley Davidson motorcycles, which is completely foolish. The idea of dependent just does it change the probability at all? And the probability is a woman should do what? Drop. Not become 0. Nobody ever said that shit, but it definitely will be less. Why? Because there's more dudes riding Harley Davidsons. Not no women, but more dudes. So it's all a question about how does the probability change? Not do I need this to happen before this happens? Or if this happens, now it's a 0% chance it could be a woman. That's not what that says. It's, does the probability change? I like it. Okay? So here's how to do that then. I really want you to get this idea. Every semester I try to, all right. I can't answer a question about if two events are independent without analyzing something that shows me how they interact. Let me say that again. I cannot answer a question. I love some of you guys are tuning me out. That's all right. I'll keep going. I'm a math teacher. I'm used to it. I cannot answer a question about if two things are independent or not without doing some math that shows me how they interact. You with me? So like if I thought you were dependent on your mom, I can't really tell unless she's in the room with us or I get, some kind of interaction, right? Then I can tell better. Oh, you're waiting for her to answer the question. What the shit? Whatever. You guys kind of with me a little bit? Not the best example, but par for the course with Jeff. All right. So what does that mean then? Here's the test. If I ask you, are A and B independent? The fewer words you use to explain the answer and to do it, the better. You cannot answer this with a paragraph. Well, some women ride motorcycles and no. It's a purely mathematical idea. You check out this. If the probability of A given B is the same as what the probability of A was to begin with. Do you see what does that say? B happens, does A give a shit? No. We do it again. Given that B happened, does the probability of A change? If that's true, if it doesn't change, they are independent. That just makes sense. A didn't give a shit that B happened, stays the same as it was before, independent. So the example I said earlier, probability as a woman is 50%. Probability as a woman, given that she just came off of a Harley Davidson motorcycle, less than 50% now. That would be dependent. If that's true, A and B are independent. Otherwise, dependent. I like it.
Would that be like, so if you were to like switch it, just to use an example, if the person got off the motorcycle and they were what seemed to be like super, super tall, that wouldn't change it and that would be considered?
Oh, I don't know. We don't know enough probabilities. Is there a higher percentage of people that ride motorcycles that are tall?
No, I was saying like a man, because you thought it was a man, and if he was tall, that wouldn't change your probability of thinking it's a man. Or,
If I see a person and they're walking towards me and they're really tall, it is a higher chance that they are a dude, right? And again, not saying it's impossible to be a woman, but most of the really taller people are men, because men get taller on average, right? That's not saying it could not be a woman. I always gotta cover my ass. You show
it's
the
not a problem.
yeah,
That's it. It's just
but
not a problem.
yeah, statistics. You could do a statistical problem in purely mathematical analysis, and people get upset because they think you're trying to say something politically or something. It's all frickin' numbers. The interpretation is something else. But this one is
Example
just
of an independent case?
okay. You ready? All right. Independent is really hard to come by in the real world because almost nothing is totally independent. But let me give you this in the real world. Are your car battery being dead and your fridge being dead dependent or independent?
Independent.
Independent. It's not like your fridge is like, car's still good. Car's dead. You know. So they don't affect each other, right? But when I start talking about people and such, I mean, there's so many ways we can affect you know, so it's hard. Here's a really good one. So everybody's pretty good with cards, is that right? Cards, yes. How many suits in a deck of cards? Four. Hearts, diamonds, spades, clubs. Right. How many kings are in a deck of cards?
4.
So what's probably I pick a king if I pick one card?
4 out of 52.
4 out of 52. I like it. So 1 out of 13. What's the probability I pick a king given that it's a club?
1 out of 52.
No.
1 out of 8.
No. So there's 4 suits and there's 52 cards. So how many suits, how many cards in each suit? 52 divided by 4, 13. So there's ace, which we'll consider low, right? It's like 1, up through king, which is like 13. You guys with me a little bit? And if you don't know cards at all, you didn't speak up earlier, so go with it. So basically, you have ace, 2, 3, 10, jack, queen, king, and you've got 4 sets of those. 4 times 13 is 52. So you got 52 of cards. No jokers. No. So given that it's a club, what's the bottom become?
13.
And out of those clubs, how many are kings? 1. So are king and club independent? How do you check it? Is the probability of king equal to the probability of king given club? Yes, therefore they are independent. Knowing that a card is a club does not change the probability it's a king. Okay. Pained expressions are fine because that means you're trying to think about it. Yes?
So for the exam, what type of questions would you exactly ask us about a life? Because I understand the cards, I just don't understand what you mean.
I've got a little
People
handout.
examples.
I've got a handout and I've got the practice quiz that'll show you the kind of questions I like to ask. Very often I like to ask the independent question with the table question. You remember the table with the man, woman, yes, no, whatever. Okay. You'll see exactly what it's going to look like, and I'm not going to make it a lot different. Okay. Is that all right by itself? What's the probability it's a king given it's a face card? What the shit, Jeff? How many cards have faces on them? 3 for each suit, so a total 12, yes. I like it. So given it's a face card, what's it going to be out of now?
12.
Out of 12. How many of those are kings?
4.
Still all 4. So if I know it's a face card, my probability it's a king just jumped way the shit up. Okay, maybe. From like 7% to 33%. Almost 5 times the chance. I like it. Okay. Can I shut up now? Let's see. Carol, that's what I've been wanting. Stop. Yes, I can shut it now. Here, you guys try this out. If you need to borrow a calculator,